In my previous video, I showed the development of the induced surcharge envelope curve, which for some dams will determine the spillway gate openings that need to be made when you're out of flood storage. Now what I wanted to do is actually show how these curves would be used in real-time reservoir operations. So if you recall, you need to develop an inflow forecast from the observed rainfall and then develop a release schedule. And what you do is then you plot your peak elevation that will be achieved along with the peak release. And this is going to be an iterative process that occurs. So you can see in my first iteration, I said, well, what happens if we just release 0 from the reservoir? And that's shown by this red dot. So we have a 0 release, but you can see that the elevation is above the induced surcharge envelope curve, which is shown by this blue line. And recall that that's the maximum elevation. And so since we're above the maximum elevation, we're going to need to do another release schedule, or another iteration. And so here we do this, and we have a peak release of about 20,000 CFS, but we can still see that our peak elevation is still too high for that release, and so we'll do another release schedule. And in this case, it looks like the peak release is roughly about 35,000 CFS, and it looks like that we're below the elevation, below the envelope curve. So in this case, we're okay. And you can, in real-time operations, you can fine-tune this even further if you wanted to get right on the envelope curve. But just as long as you're at or below the curve, you're okay, you're satisfying the conditions of this envelope curve. Now I pulled this statement out of the Corps of Engineers Engineering Manual 1110-2-3600. It's the management of water control systems. And it deals with operating based on forecast. And this directly applies to these induced surcharge envelope curves. And it says that if the forecast based on observed precipitation, and recognize that this word forecast can be a little bit tricky. It's basically talking about an inflow forecast that's based on observed precipitation. And if that indicates that you're going to run out of the remaining reservoir storage capacity, which means that you're going to have to open up your spillway gates, it says that you can open up these gates before the time required using the spillway gate regulating schedule. But there's a couple of things that you need to take into account about this. First, if you open up the gates early, it will typically lead to a lower peak release from the reservoir. And that might seem like an obvious step to take. However, you do have to take into account what's going on downstream to make the determination on whether or not you should be doing that or not. So for instance, if you have a significant rain event that's occurred in your reservoir, but all the forecasts are showing that the rain has moved out and you're not going to get any more rain, and also you're not having a flooding issue downstream or that downstream has peaked, in that case it would make sense then to start those releases early, because you can get a better downstream result by having a lower peak release from the reservoir. However, if you just had a significant event occur in your controlled area and you have a lot of inflow coming into your reservoir and that storm appears to be moving into the uncontrolled area, it may be more advisable to wait to see what happens, because if you're able to fill in on the after the peak, then that can be a better result than trying to release early and possibly contributing to that downstream peak. So this is a case where a real-time reservoir engineer would actually use forecasted rainfall to help make a real-time operations decision. But again, the determination on whether or not to open up the gates early or not, is one way you do have to look at rainfall forecast, and you do have to look at what's going on downstream before you make that determination. I also wanted to show what would happen if you were to alter the induced surcharge curves and how that may affect real-time operations. If you recall, this curve has this shape or this steeper slope to try to provide additional benefits at the more frequent events. And remember, when we're talking about more frequent events, we're talking about lower pool elevations. And so it may be desirable to try to extend those benefits to less frequent events. And so what I'm trying to show here with this green dash line is that I'm trying to make this steeper slope go out further in order to provide additional benefits at maybe a higher elevation or maybe a less frequent event. But if you notice, it can create problems for real-time reservoir operations because the curve will get pretty flat in this area, especially if you have to keep the fully gate open or the fully open gate elevation the same. The problem with having this be very flat is that you're starting to get very significant increases in discharges with very small increases in flow, and it can be very difficult to operate to. The other issue is that I'm actually allowing the pool to get higher. I'm actually letting it rise closer to the fully open gate elevation earlier in the event, which means, again, that I'm probably going to have to make some very significant releases if this event becomes more severe, and that may give me a less desirable result downstream. So you may decide to try to push this out further to give you more benefits at these more frequent events, and also try to keep this slope the same, which would lead you to a higher elevation for having the gates fully open. However, the same considerations that went into determining this original fully open gate elevation are still going to be present here. So you're going to still have your concerns with dam safety. You're still going to have your concerns with access to the spillway gates. Make sure that you're not cutting off the spillway gates to where they would not be able to get the gates fully open. And you're also going to have the concern with upstream flooding, and that can be for people who live around the lake, but also from backwater effects that can be caused by a high lake elevation. So thanks for watching this video. I'll be producing more of these videos as I have time. If you're interested in finding out when another video comes out, feel free to subscribe to the channel, and thanks again for watching this video.